want to see you over on your right. One and 5 and 2 look like the majority, so we'll do a 3. We haven't really touched on this, but we're actually going to talk about this today. So I'll explain what this is, and then we'll go further into it later. When you're looking for something that is a function, you're looking for repeating x's. If you see repeating x's that go to 2 different y values, it's not a function. So in the first one, I see that each x value is its own, so it doesn't have repeating x's, so I don't even have to worry about that. And B, I see a -3, a 3, but I see 2 of the same x's, the 1, and they go to 2 different y values. That's B. While putting this on Desmos would help you see it, you still have to know what you're looking for, so Desmos only helps you so much with functions. Number 2, we talked about domain and range of quadratics. That the domain would be everything left to right. It would go to negative infinity up and left, and go to positive infinity up and right. And that would be the same thing as D. And you have to recognize that those are the same. And then again, Desmos will help you see the graph, will help you see domain and range, but if you don't know what you're looking for, that won't help you. So again, domain is going to be the same for number 5, all real numbers. For range, you're looking lowest to highest, so the lowest value is at -4, and it's everything above that. So y is greater than or equal to -4, and the vertex would be the highest or lowest point, which is 0, -4. Desmos will help you find the vertex, but you, again, have to know what you're looking for. Questions on those? Okay. Look at your notes. So some of this will be familiar with you, some of it will not. For this, also this is starting unit 12, and there's only 2 more things after today that we have to talk about, and then we will have covered everything that's going to be necessary. So for this, an ordered pair is a set of numbers or coordinates written in the form with parentheses x, y. A set of ordered pairs is called a relation. We're going to talk about some other different types of relations also. So here we are given a table. How would I describe the left side of this table? What words could I use to describe it? The x values. What are some other ways to describe the x values in this table? Infinite variables. There's one other way we can describe an x that will be part of how we describe an x, but not what this part is looking for. Think about if you had some equation and you were putting things in for x to get out some y, that would be an input. So then the opposites, the right side would be
Output.
output.
Dependent.
Say again.
Dependent.
Dependent variables
And Y values.
and y values. So we need to remember that all of those mean the same thing. So if you see something that says x values or input or independent variables, all mean the same thing for y's. And then the first set of numbers in the order pairs are all the x's, refers to what Kim said, the domain. So those are also interchangeable. Second set of numbers in the order pairs are all the y's, refers to the range. And this last one is a mapping. Illustrates how each element of the domain is paired with an element in the range. So now we're going to talk about the different types of relations and how to do a mapping. So on the next page. I don't know why board does not like these fonts. So let me return. There are 4 ways a relation can be represented. It talked about order pairs on the previous page. A table is another one. Mapping and a graph. So besides the mapping, pull off on that one. Go ahead and make your order pairs and go ahead and graph those points. With your order pairs, though, start off with a curly bracket and then write each order pair in parentheses, because this is the set of all of these order pairs. Make sure you have your order pairs in your graph. Then when we do the mapping, we're going to list out our domain and range in curly brackets, just the numbers from least to greatest. So looking at my graph, least would be starting at -7, and then we have -4, 0, 3, and 5. If you had any repeating x's, you would only write it once. And then for the range, you're going to do the same thing, least to greatest, starting at -6, -3, 1, 3, and 5. Then you're going to take those numbers and you're going to write it in these ovals. Domain is your x's, so write it in that one. F of x is the same thing as y, so write those in there vertically in order. Then the last part of the mapping is to literally map the x's to the y's. So in the order pairs or the table or the graph, whichever x's and y's went together, so like -7, -3, I would draw a line that connects them. -5, 6, and so then, those are the 4 different ways we can represent a relation, a mapping, a graph, ordered pairs, a table. You have to recognize each one. And in this last part, a function is a relationship between the input or domain, x values, independent variable, and the output or the range, y values, dependent variable. In a function, there's exactly one output for each input. So if I were looking at the examples here, each x value has exactly one y value, and that's what it means to be a function. We're going to try some examples on the next page. For each example, off to the side, it doesn't matter which side, draw in a table, because it's missing that. And then starting with number 1, we're given the ordered pairs already, so we're going to go ahead and fill out the graph, fill out the mapping, fill out the table, and then we're going to figure out is this a function or not. So go ahead and start to do that. When you're doing your mapping, make sure you're not putting repeating numbers, only put each one once. So then once you have your mapping, your table, and your graph, we're going to look at whichever, it doesn't matter, to see do we have repeating x's. So let's answer that question first. Do we have any repeating x's? No. So then because we don't have repeating x's, we can say that every x value has its own y value, so this is a function. I do see that my y values have multiple x's. That's okay. This can happen. You can have multiple, you can have that y go from different x's, but you can't have this x go to different y values. Do you have any questions on that? Go ahead and start filling out number 2. In your table, make sure your x's are in order and then your y values just correspond to whatever that is. As we're looking at our ordered pairs, the table, the graph, the mapping, do we have repeating x values? Yes. What is that repeating x value? 5. So you could find that in the ordered pairs, in the table, in the graph, or in the mapping. Because this x value has 2 different y values, this is not. Have any questions on how we determine if something is or is not a function based on the graph, the table, the mapping, or the ordered pairs? We're not going to do 3. You could do that at a later time. Go on to the next page. This is the vertical line test. And we use the vertical line test as another way to see if something is a function or not. Works best on graphs. So if you were to draw a vertical line anywhere on the graph, or you could draw multiple, if at any point it touches more than one point or place, it fails the vertical line test, and then it would not be a function. If you draw in vertical lines or just one, and it only touches one point or place, then it passes and it is a function. So, in these examples, if I were to draw in a vertical line through these points, this one, okay, that one should have went through the other one. Anyway, if I were to draw a vertical line at all of those points, does it touch it at more than one place?
No.
No. So that means it passes and it is a function. If I do the same thing for the second one, does that touch more than one point?
Yeah.
Yes. So that fails and it's not a function. Would the bottom left be a function? No, because it does not pass the vertical line test. What about the last one?
No.
So that one actually would be. As you draw in vertical lines, it only touches at one place. So that one is a function. Do you have any questions on how the vertical line test works? I'm going to give you the next 5-ish minutes to try as many problems as you can on the next 2 pages, asking any questions you have. Stay at your seats for this, and then afterwards we'll move on to something else, and I'll explain what that I think is a function. You need to go over any of those. So then everyone should have a packet that looks like this. On your desk. This is your next SOL packet. But not like the test have. You're going to be working on this in class today, and it's going to be like the math gap. So you can work together, you can use Desmos, cannot use your notes. You're going to start on the first page, everyone is going to start on the first page, and you're going to try to do those as much as possible, do as many as you can, work together. Then you're going to come to me, everyone is going to come to me to get each page checked. I'm going to go through, if you have any that need fixed, I'll highlight it, you'll go back and fix it, and then you'll come get it checked again, and then I'll score it. And then you'll move on to the second page. So you can work together, but everyone needs to come get each page checked. Anyone have any questions?